All right, so we talked about simplifying rational expressions the other day. This is a very small step beyond that, not much at all. Okay, so if we want to find a product, we're going to multiply rational expressions. Think back to what we did the other day. If we started off with a rational expression and we wanted to simplify it by just canceling like factors, do you see that this is essentially the same thing? Right? How do you multiply fractions? Straight across, right? It's easier than adding or subtracting. You don't have to worry about a common denominator or anything. You just multiply straight across, right? So in this case right here, what do we get? We've got, this rational expression times this one. I can just rewrite that if I want to. On the top, I've just got the factor x minus 1 times the factor x plus 4, so that's kind of nice. It's already factored, right? We don't have to break that one apart. And then underneath we've got the factor x squared plus 7x plus 12 times x minus 2, right? Does that make sense? We want to get to a point where we can cancel like factors. So what else do you think we could do here? Let's put all the phone there. Okay, good. So the white factors up here are already done. We can't go any further with those, right? They're already linear, so the biggest power of x is 1, and there's no greatest common factor for us to factor out. The yellow one, though, is quadratic, so we want to see if we can break that apart. What does that break apart into? We know we've got a is equal to 1, right? So we know this is the template. What were the magic numbers again? 4 and 3 that multiply to 12 and add to 7. So then we end up getting on the top, we've got x minus, that's bad, x minus 1 times x plus 4. On the bottom, we've got 3 now, right? X plus 4 times x plus 3 times x minus 2. Okay, any cancellation? The x plus 4s cancel. Good. Okay, so those guys are gone. What were you going to say?
I said if you combine them two on the bottom, you get x.
Okay, so maybe you're thinking of the next step. Maybe we'll see. Because then, so those cancel, and then I think what you're going to say is you can multiply those out, right?
Sure.
Is that it?
That's what I meant.
Okay, good. Because that's what we want to do, right? We want to write this in simplified form. So on the top, we just get an x minus 1. And I don't even need parentheses around that anymore, do I? It's the only thing on top. And on the bottom, I've just got to multiply those factors out, right? So what's that going to give me? Hey, how am I going to do that? How am I going to multiply x plus 3 times x minus 2? Distribute. Good. So if I distribute the x, what am I going to get? Minus 2x. Good. If I distribute the 3? 3x. Good. And if I combine those like terms, what's negative 2x plus 3x? There it is. Right. Make sense? Okay. One last question for you, and this won't show up on, I don't think on this assignment either, but it's coming. What would be the values of x that I'd have to exclude? So what values of x would I have to exclude? And why? Why would I have to exclude any values of x? Okay, so here's a factor, right? Any value of x that makes us divide by 0 has to be excluded. So on the bottom, I've got the product of these 3 factors right now. Sure, the x plus 4s did cancel, but they were there originally, right? So they're a part of the original product. So we need to consider those, right? By the zero product property, what are the values of x that would make the denominator 0? Say it again. Not 0. If I plug 0 in for x, look what I'm going to get. I'm going to get 4 times 3 times negative 2, which is not 0. If I plug 1 in, I'm going to get a 0 on the top. But that's okay, right? I can do that. I can divide 0 by something else. What's 0 divided by 7? That's an answer, right? We can take that one. But I can't divide by 0. So negative 4 wouldn't work, right? If I plugged in a negative 4, I would get 0 times negative 1 times negative 6. And I don't even care about the other two. I just care about the 0 times part. 0 times anything is 0, right? So that's one that's going to give me problems. If I let x, if it were to equal negative 4, I'd have to divide by 0, which I can't do. What's another one? Negative 3. That would make that factor 0. And 2. Okay? All right, let's try another one. You guys try that. You guys try that. Get out your notebooks. Same kind of a thing. This one's a few more things going on, but you'll get it. Now remember, we don't always get a chance to do this, but anytime we're factoring, we always want to see if we can factor out a greatest common factor, right? Every time. We haven't had a chance yet, so that means undistribute. We always want to undistribute something if possible. Suggestions here. So maybe it's helpful to write everything out. At least you can see it a little better, right? If we write everything on top all joined together. So I've got how many factors on top right now as it's currently written? 3. Good. Okay, so a couple things. Now this isn't essential, but a lot of times what we'd like to do is we want to write the constant factors out in front. So let's put the negative 7 out front. So we get a negative 7 times a negative x squared times an x squared minus 4. Okay, on the bottom, we've got x minus 2 times 7x minus 42 times 4x squared plus 8x. Okay, and at this point, it's not like there's any one way to do this. There's just a bunch of stuff to do. What do you see? Some ideas. And there's no right or wrong answer here.
Okay, it's probably wrong. I, on the 4x squared plus 8x, I divided by x squared plus 2x.
Okay, so you divided by 4. Okay, that's a good start. Now, if we're going to find the product here, notice that we've got this big expression, and we want to know what it's equal to in simplified form, right? Now, when we divide by something, let's think about this. If I had something like, for example, now try to see the difference between these two situations, because this is really important. If we had something like, let's say, I'm going to go to the next page. Yes. 4x squared plus 8x. Let's say that equaled, well, say it even equaled 0, okay? And we were trying to solve this thing. I've got an equation up there. What are the rules for an equation? Well, as long as I treat both sides equally, anything's fair game. I can't divide both sides by a variable, right? Because I lose a solution. But I can multiply or divide both sides by a number, right? And so Hunter's suggestion is a good one. If I divided both sides by 4, I would end up with x squared plus 2x equals 0, right? Now what?
You do x plus 2, like, can you factor it?
Yeah, okay, I can factor that. How do I factor that?
X plus 2 and x plus
Okay, x plus 2 and what is x plus 0?
Wait, what?
What is x plus 0? Just x, right? Okay. And I think what you were doing maybe is you finding magic numbers that multiplied to 0 and added to 2, right? Okay, that works, but that's overkill. Remember that we always want to just see if we can undistribute something. What could I undistribute? Yeah, I don't see everybody's eyes up here. That bothers me. If they're phones or anything, I'm about to make a little circuit here. I want phones away. I do not want people being distracted because you're not going to get this then. And if you're not getting this, I mean, I don't want it to hurt you, but it's going to hurt you guys because you got tests coming up on this. We're getting near the end of the year. Just do yourself a favor and try to get it now so you can, don't have to figure it out on your own. It's hard to figure this out on your own, but it's not so hard if I'm going to guide you through the steps. That's my job. Let me do my job. So what could I undistribute here? What could I undistribute? There's no numbers. Say it again. X, yeah, I could undistribute an x, couldn't I? Right? An x would divide into both of those terms. If I wanted, like for example, if I said x squared divided by x, what's that equal to? X. Okay, so if I undistribute an x, it means I'm dividing it out front. X squared divided by x is x. So we'd end up with an x. What is 2x divided by x? 2x divided by x. 2, right? The x's cancel. Right? Everybody agree? So that's what we get. And so what would the solutions be then? I've got this thing factored. I can use the zero product property, right? I could just ask the question, when does x equal 0? Well, when does x, it's 0, when x is 0. That's the solution. That's one solution, isn't it? This factor right here is equal to 0 when x has the value of 0. What about this factor here? When does x plus 2 equal 0? When x equals -2. Okay? So those are the two solutions, right? Dividing by 4, and why did we bring this up? Dividing by 4 was a great idea. It made it simpler. Okay? Now, in this context here, though, we can't divide by 4 because it's going to change the answer. If I divide by 4, this product is going to end up being something different than it would have been if I hadn't divided by 4, right? I'm just trying to find an equivalent, simplified version of that big mess, right? So I can't divide by 4. What do I have to do instead to make it simpler? Take this factor, and what can I do with that factor? I'm trying to break them apart as much as I can to see if I can cancel anything, right? So what can I do with that one? How can I make it simpler? I don't divide by 4. What do I do with the 4? Undistribute, right? I'm going to undistribute the 4. I'm going to factor it out. So I could take this part, so this guy right here, I could undistribute a 4. What else could I undistribute? An x, yeah. I could pull a 4x out, undistribute it, and get what? What's left behind? 4x times what is 4x squared? X. 4x times what is 8x? Right? So all this stuff would just break apart into that. So that's helpful, right? What about, let's see, what about this right here? Could I undistribute anything from that one? I can undistribute a 7, sure. So that's going to become 7 times what? 7 times what is 7x? X. Okay, 7 times what is -42? Okay, good. Now this one I'm stuck with, right? Oops, that's back color. Okay, that one I'm stuck with. What about on top? Well, those two are monomials. There's nothing I can do there. I could do this. What's negative times negative? Positive. So everybody see that I could do that. I could just make each of those positives, right? Cancel out the negatives. That's a little bit helpful. So those two I'm stuck with. So I get a 7 and an x squared. But what about this one here, the last one? How does that factor? Well, I can only undistribute something that I can, if it exists in both terms, right? Like here I was able to undistribute an x because both of them had an x, and a 4 because 4 divided evenly into both of those numbers, right? What about the x squared minus 4? How am I going to factor that? Let's just focus on that one for a second. This is a good opportunity to do a little bit of review. We've talked about this in the past, but it's been a little while. So x squared minus 4. There's two ways I can do this, and one way is the way I'd like you to do it. It's a little bit easier. If we're factoring, this goes back to our whole polynomial thing, right? When we're trying to break apart or factor a polynomial like that has two terms, we had some patterns. You remember what they were? Right? We had some sum and difference patterns. See if you can fill in the blanks, because there's not much, there aren't a lot of things I think in math that I really want you to memorize. Because you just forget things that you memorize. But every time you memorize them, it gets a little bit easier, right? So you may have already forgotten these, honestly. I would understand. We haven't used them in a while. We've been doing SBAC prep. But we had a bunch of patterns. We had a squared plus b squared, a squared minus b squared, a cubed plus b cubed, and a cubed minus b cubed. Okay, do you remember how those all work? Now, one of them, remember, was a trick. There was no pattern. Only three of them.
A squared plus b squared.
A squared plus b squared, there's no pattern. So it's just plain old a squared plus b squared. Right? So that one's a trick. You can't do anything with that. But a squared minus b squared, we called that a difference of squares. Right? Something squared minus something squared. How did that factor? How did that always break apart?
A plus b
Times.
a minus b.
Very good. A plus b times a minus b. Good. Okay, that's the most common one we use. The other ones we don't use as much, and we won't use them here. Probably. Maybe there will be a couple of these. These were a little tougher, but there was a way to remember these. Remember, both of these look very similar. There was a small factor and a big factor. And here's kind of the way to organize our thinking on this so we can remember it. The small factor, the two players, or the two terms, were just an a and a b. And in the big one, remember what they were? A squared. Well, what was the middle one?
2.
Not the 2. I know where you get the 2. The 2 comes from a different pattern that's similar. But this was just an a times a b and b squared. Okay, and all we had to do here, once we got that part filled in, was just put the correct signs in, right? So if it's a cubed plus b cubed, what goes there? Plus, right? Whatever the sign is between the cubes, it goes in the first one, right? What goes there? Minus, because it alternated. And then the last one was what?
Plus.
Always plus. Good. So then down here, if I have a difference of cubes, it's minus, plus, plus. Yeah. Okay, good. So then x squared minus 4, which one of those would fit?
Kind of, no, I'm just kidding. A squared minus b.
Okay, so the one it could fit is a difference of squares, because I have x squared minus a number. So can I write this as something squared minus something squared? Well, obviously that's an x. 2. Okay, so a is x, b is 2, and what does that factor into?
X minus 4.
If it's x squared minus 2 squared, it's just well, what's that pattern say? If it's a squared minus b squared, it's just a plus b times a minus b, or a minus b times a plus b. It doesn't matter which order. So that's my a and that's my b. It's x squared minus 2 squared. What do we get?
X. 4. X minus 4.
No, because it's not. Because b is not 4, is it?
Well,
What's
Yeah,
b?
It's negative 4.
No, b squared is 4.
Oh,
What's b?
2.
2. Ah, okay, so x
2 plus 2.
plus 2 times,
X minus 2.
there you go, right?
That was
Okay, so all we got here then, on this page, we just got to take this, where were we? Oh, wrong problem. Oh, it was up at the top, wasn't it? There we go, yeah. So we want to take this guy here, and we just wanted to break that apart into its factors, which were x plus 2 and x minus 2, right? Everybody see what we did? So let's rewrite that. That's kind of a mess. So we end up with, then on the top, we get that whole string of things. 7 times x squared times x plus 2 times x minus 2 divided by x minus 2 times 7 we should put out front probably, right? There's our 7. X minus 6 and x plus 2. Oh, and I got a 4x there too, don't I? Okay, so, okay. Okay, so then what cancels? 7s. So the 7s cancel. Anything else?
X minus 2.
The x minus 2,
X plus 2.
the x plus 2. So then we're left with, on the top, what do we got? I get 1 times x squared times 1 times 1. So I just get an x squared on the top. What about the bottom?
4x.
4x times x minus 6. So I would just distribute then, right? So if I distribute the 4x, what do I get?
4x squared minus 4x.
There you go. Boom, that's it. Okay, and actually there's maybe one more thing we could have done there. Let's go back.
Divide by 4.
I can't divide by 4. But there is one more thing we could have done. I want to go back and, whoops. One last thing. Notice I've got an x squared divided by an x. They cancel too, don't they? Right? What is x squared over x? X. Okay, so I could cancel that x with one of those, leaving me with just an x on the top, right? So we end up then, say it again?
What about the other x?
There's an x minus 6 there, right? So on the bottom then, I've just got x minus 6. So here's what's left. X minus 6 times 4. And on the top, all I've got is an x. I can't, okay, I see what you're saying, like cancel those. I can't do that because this x is not being multiplied. It's being, x and the minus 6 are being added or subtracted. See what I'm saying? You can only cancel factors. So we end up with an x on the top, and if I distribute the 4, I would just get a 4x minus 24. Everybody see that I can't cancel those x's because this x is not being multiplied.
So, but if it was like 4x times 24,
Then you could, absolutely, then you could. Okay. See if we can get one more in here. Tell you what, I'm going to skip ahead. I want to look at this one, last one. Maybe, we'll see. See how much time we have. Find the quotient. So quotient means I'm dividing, right? Now I want you to, this looks like, oh man, it's going to be hard. We're doing division, right? Division is no harder than multiplication. There's just one small additional step. Multiplying and dividing rational expressions, relatively easy. Adding and subtracting is maybe a little more difficult, but this really is no big deal. I could also write this, and I'm going to do this. I could also write this if I wanted to, instead of using that dorky division sign like you used, way back in middle school and elementary school. We could even write this as negative x over 2x plus 8 divided by, using a bar, much better, this other rational expression, x minus, x minus 2 over x plus 4. Either way, what do you do when you divide fractions?
Oh, common denominator.
No, that's adding or subtracting. Now just think about this. What do you do when you divide fractions? If I have something like 3/4 divided by 2/3. No? think back to all those, you would have done tons of this in the past. Maybe it's just been a little while. But if you did something like 7/3 divided by 3/2, if you divide by a fraction, you flip and multiply, don't you, right? So that would have been equal to 7/3 times 2/3,
No.
right?
Oh, yeah.
Flip and multiply by the bottom, right? So we're gonna do the same thing here. Okay, so then we're just going to flip the denominator, which either is there or there, doesn't matter, right? And we end up with a product. It's a pretty simple product then. Negative x over 2x plus 8 times the reciprocal of the bottom would be x plus 4 over x minus 2. And all we've got to do is just factor everything that we can. So I could just extend this bar, right, and make this and put parentheses around the factors. And what's the only thing there I'd have to factor at all? Of those 4 factors, what's the only one I could break apart at all?
2x plus 8.
2x plus 8, what could I do there?
Well, you could distribute the 2, or the x.
Undistribute the 2?
Yeah.
Right, so I could factor out a 2, right? We say undistribute, but really in math we should say factor out, right? It's the greatest common factor. So I could take this one and break it apart into 2 times x plus 4, right? And so then we end up with negative x times x plus 4 divided by 2 times x plus 4 times x minus 2. What cancels?
One of the x plus 4.
Yeah, so those guys cancel, right? And we just end up with negative x over, if I distribute the 2,
2x minus 4.
there you go. Right? No biggie? Okay. All right, last one, let's see if that's worth looking at. Yeah, I don't know, I think you guys can, just go ahead and grab a Chromebook and jump in and try a problem or two on that. It's the second assignment. There's two very short assignments from this is section 7-2. One very short one where you multiply and one where you divide some rational expressions.